Hello everyone. Today we are going to discuss the fourth problem of Leetcode Weekly Contest 380, which is find beautiful indices in the given array 2. So the second problem is also the same, but the constants are different. Here you can see the constant on length of n is 5 into 10 to the power 5, and constant on length a and b is 5 into 10 to the power 5. But for the second problem, the constant on length a and b is quite less, like 10 or something. So what is the problem? Let's understand the problem statement first. So the problem statement is we are given three strings is a and b and an integer k. So this is quite formal statement, so I'll try to explain it with some example, right? So let's take some example, like is, let's say, is a b c d a b, right? Now let's say this is s, and let's say a is like that, a is ab. Let's consider a is ab, and let's consider b is cd, b is cd. So and let's consider k as 2. So let's consider k as 2. So we have to match some substring from a, substring from s to a. We have to match some substring from s to a, and we have also to match some substring of b, s to b, right? So here you can see that the first two the substring from 0 to 2 is matching with a, and the substring from 2 to 4, if you are using zero based indexing, is matching with b. Now after you have matched two substrings of s from to a and b, you have to check the difference between the first indices of this matches. Like first it is 0, and for matching with b it is 2. So the difference between the starting indices for the two substrings we have matched with a and b should be less than equals to 2, the absolute difference, obviously. So here is the formal problem statement. So 0 could be from I could be from 0 to s length minus a length, and we are taking the substring should be equal to a. The substring from I to I plus a dot length minus 1 should be equals to a, and after that we have to find another index j such that 0 less than j less than equals to s dot length minus b dot length, and similarly we have to match the substring of j to j plus b dot length minus 1 to b, and after that the absolute difference between j minus I should be less than equals to k. I hope you understood what the problem statement is. Now if you take the first example, the example is quite big. So what you have to check that the something is matching with a. So my is here, so it is matching with a. Now something is matching with b, so this is squirrel is matching with b. Now we have to take the difference between this indices of this s and indices of this m. So the difference is 16 minus 4, 12, which is less than equals to 15. So we are pushing 16 in our answer. Similarly, if you check for the 33rd index, you will again find the 33 minus 18 is less than equals to 15. So this is also be pushed into the answer. So our answer will be 16,33. So how we can solve this problem? So let's try to solve the problem with the previous constants, where length on s is 5 into 10 to the power 5, but length on a and b is 5 into 10 to only 10. Okay, here the length constant is 5 into 10 to the power 5, but we will first try to solve the problem for 10. Okay, so how can we solve the problem for 10, right? So let's take this. So let's say first we have matched all the indices which is matching with b, right? So let's say we have some set containing of indices which is matching with b, right? So let's take this example only. B is cd, so we'll only push the index of this c in our set. So index of this c is what? The index of this c is 2. Now we'll again iterate over the string and try to find the substring which is matching with a, right? Or you can do reverse also. These are quite symmetrical, so it is also possible that you first do for a and then try to do for b, right? Now again what we are doing, we are trying to check what indices uh, are matching with a. Now we will check that 0 index is matching with a, because this a to b is matching with ab, right? So we will try to check if this what is the if there is a match for this 0 in the set. Now we'll check that the lower bound of 0 in the set is 2. Now we'll check 2 minus 0 is greater than less than equals to k. So 2 minus 0 is equals to 2, which is less than equal to k. So we'll put this 0 in our answer, right? So now let's solve this. Try to take the first example. Now for the first example, you can check that this is one squirrel. So one squirrel is at index what? Index what? 0 1 2 3 4. So our set is will contain 4. And what is the next value of the match? The next value of match is here. Next value of match is here. Here you can check that the index is 18. So our set will contain 4 comma 18. Now we will try to do for a. We will try to check for a. Now for a, our first match is at here. Our first match is at here. So what is the index? 16. So we'll try to find the lower bound of 16. We'll find the lower bound of 16 is at 18. Now the difference between them is less than or equals to k, so we'll put 16 in our answer. Or you can instead of let's say instead of 16 we get like something like 6. Now and k is let's say 10. So when we try to match 6 with 18, our answer will fail. So we have to check for the lower bound and the item which is less than lower bound also. So we have to check with 4 also. So we have to match two cases, one which is immediate greater and which is immediate lesser. Okay, so I hope you got the solution approach. Now the rest of the part is how we can solve the problem for bigger values of length of a and length of b. So this problem is this part is just important. The rest of part is quite trivial. We have to use string hashing. So what we can do, we can store the hash of a in a hash, and similarly we will store the hash of b in v hash. Now the how we can do string hashing using Rabin curve algorithm, you all know. So we have to do a kind of rolling hash, like we have to take some sliding window of size a length. Okay, for matching with b we have to take a sliding window of b length, and for matching with a we have to take the sliding window of al. Okay, so when we are let's say let me explain the Rabin curve algorithm to you. So the Rabin curve algorithm for something like S0 to SL will be like that. It will be like S0 into base, let me call it as a b, capital B. So S0 into b to the power L plus S1 into b to the power L minus 1. I think this will be L minus 1 only. S1 to the power S1 into b to the power L minus 2 plus dot 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 plus I think it will be S of L into b to the power 0, right? I hope you got it. So this is the hash algorithm for Rabin curve, and we have to take something with bigger modulo, right? I hope you got it. Now when we are doing some kind of sliding window approach, so now let's say we'll add something like s of l plus 1 in our in the hash, right? What will we do? We'll do something like let's consider this as h. So our hash will be updated as h equals to h into base plus our new index s of l plus 1. Okay, so what you can see that everything is getting multiplied by capital B. So S0 will be multiplied by capital B, S1 will be multiplied by capital B. Now after that, now our length of the string is exceeding L. So length of the string is exceeding L, so you have to just discard the leftmost index. We have to just discard the leftmost index. So what is the power of the leftmost index? Now we notice that we have already multiplied it by b. So we have to what is the power of s0? Our power of s0 is nothing but b to the power l. So after calculating this h, if length of the string is greater than l, we have to subtract h equals to h minus s of what we can say s0 into b to the power l, right? Right. After we are done with the hash, we have to check if it is equals to ah or bh, right? Now let's jump into the code. I will try to explain how I have solved the problem using hashes. So this hash functions will try to generate the hash of a string using Raven-Karp algorithm. The function hash function is this. I have already explained. Here you can see answer is the hash into base plus I minus a plus 1. Okay. So here hash base I have taken as 27, or you can take any other big integer, and our modulus I have taken is 1 10 to the power 9 plus 7, right? Now this part I have already explained that here you can see we are multiplying a0 by b to the power l. So here pw will store our b to the power l, right? Pw will store us b to the power l. Here l will be length of b for when we are comparing it with b, and it will be length of a when we are comparing it with a, right? So here we have calculated b to the power l, right? Now for every index we are iterating and updating the value of hash. Now if I is greater than equals to bs, here I have told you that if our l value is our length of the string is greater than l, so I is greater than equals to bs, we are just doing we are just subtracting this is 0 into b to the power l. Now when we are taking something l to r, and this L to R is greater than BS, so we will just try to subtract R minus BS. Okay, so that's what I am doing here. We are doing S of I minus BS and multiplying it by B to the power L, right? Now after our comparison, after our hash calculation is done, we will check if our current index is greater than equals to BS minus 1. So why we are doing that? Let's say our A B C, so our length of B is 2, right? Let's say our length of B is 2. So when we are at index this index, we'll try to compare this 2 with B, right? So that's what I am doing. If I, our current index will be 1, I is greater than equals to length of B minus 1, 1 is greater than equals to 1. So this condition is satisfied. We will check if our generated hash is equals to B hash or not, or you can directly copy this. Using flag variable is just not needed. Now if flag, we are inserting it into our set S. Here I have taken set as S as Q because we are already using the S variable as a string, right? So similarly we'll try to generate b to the power l for as the size of a, and we'll do the similar kind of processing for a also. And when we are checking that I is greater than equals to as minus 1 and the hash is equals to a hash, so we have got some index where the substring from I minus as plus 1 to I is matching with a. We will do take the starting index of the substring, which is I minus as plus 1. Now we'll try to take the lower bound of j in q, and if u not equals to q dot end, we are comparing it with the lower bound first. If it is less than equals to k, we are just checking that flag equals to 1. If it is not, the flag is not still 1, we will try to check with the previous index, the immediate lower. We are decrementing the value of u, decrementing the u pointer. Now we will check if it is less than equals to k, we are marking the flag as 1. Now if flag, we are pushing our starting index in our answer variable. So at the end we are returning answer. I hope you got my explanation. You can find the Raven-Karp algorithm in GFG or CP algorithms. The rest of the part is quite simple, and I am also not explaining the second problem because it is a sub part of the fourth problem itself. So I will also provide the link of the code in the description box. If you find this video helpful, please like the video and subscribe to my channel. And for any doubt, you can always write in the comment section. I will try to reply each and every comment. Thank you.